right, so this week we're going to start off by looking at polar coordinates. Okay. Basically, polar coordinates are just a different way to graph. Okay. What we've done before and what you've probably done in Algebra 1, Algebra 2, and Geometry, you've used x, y coordinates, which basically x gives you left and right movement, y gives you up and down. Okay, but we can also graph things in what's called polar form. Okay, why you'd want to use polar form depends on what you're trying to do. Okay, if you're trying to sketch something, especially circular, polar form is extremely easy to do. Okay, if you're sketching things that are straight lines, generally x-y coordinate graph. That's really easy for sketching straight lines. Okay, this is what polar looks like. Okay, instead of your graph paper being set up as like a grid, it's set up as circles. Okay, and we still call this point in the middle the origin, or you call it the pole. Okay, and the axis that runs left to right, when we're talking about x and y, that's usually your x-axis. They call it the polar axis in our book. And we number it going around counterclockwise. So 0 is on the right, 90 is at the top, halfway around 180. Okay, the bottom is 270, and then back all the way around to 0. Okay, when you work with actual polar graph paper, you might see it divided up, just like you would with regular graph paper. Okay, so that's regular graph paper. Let me show you what polar looks like. Let's look at, that's polar. Right? So it's just divided up into sections. This one happens to be divided up into 30s. So it's 0, 30. Is it 30s? Nope. You know what? I think it's 15s. Let's try that. 15, 30. Yeah, that's it. 45, 60, 75, 90. So each section is just sectioned off into 15 degrees. Okay, on this one, I didn't do that. Okay, polar coordinates, we don't call it x and y, we call it r and theta. Those are the two parts to a polar coordinate. Okay, we're talking about circles. Anybody have a guess what word begins with r having to do with circles? Yep, it's a radius. And this Greek letter, what do we use theta to represent in trig? An angle. Okay. So your two parts to a coordinate are basically how far out from the center, how big of a radius, and then how many degrees do you move. All right, so first thing we'll do is just practice. If I give you a coordinate, how do you graph it? All right, so the first thing you do is you look at r, and you move out the number of rings indicated by r. Okay, as you're moving out, there's two directions you can move from the center. You can either go left or you can go right. Well, just like x, it all depends if it's positive or negative. Right? If you're given a positive value for r, you go to the right. Right? So let's say r was 3. I'd start at the pole, and I'd go to the right 3 circles. Okay, so when r is greater than 0 or positive, we're going to go right. When do you think we're going to go left? Yeah, when r is less than 0. Okay, so if r is less than 0, you're going to move from the pole to the left. Okay, so if r was negative 4, I'd start at the pole, go left 4 units, keep my pencil right there for the next step. Okay, so any question on the direction for r? Right's positive, left is negative. It's really just like the x-axis. It's the same idea. Okay, now, after you've got your movement from step 1, okay, after you've done that, we're going to look at the angle. Now, with the angle, we're moving on a circle, so we don't call it left and right. What are the two directions you can move on a circle?
Clockwise and counterclockwise?
Yep, clockwise and counterclockwise. And what do you think is going to determine whether you go one way or the other?
Negative or positive?
Negative or positive again, yep. Okay, if you've got a positive angle, counterclockwise. Okay, and counterclockwise, that's this way. All right, so if you've got a positive angle greater than 0, counterclockwise. Okay, if you've got a negative angle, clockwise. If your angle was 0, you wouldn't move at all. Okay? Just like if you had a 0 for an x or y coordinate, you wouldn't move in that direction. All right, so we got r, now we got theta. Okay? Any questions on which way you move for theta? How you figure out if it's counterclockwise or clockwise? All right. Anybody need to still copy down? Good? Yep. All right, so we'll just try like 5 or 6 examples of graphing points. We'll try all the combinations, positives, negatives, okay, everything. All right, so the first one is 3, 120. Ben, start with the 3. What does that tell me to do?
To move 3 to the right.
Yeah, if r is positive, move from the pole to the right 3. Okay, and now we're going to start from right here. And Chris, I'm going to go 120 degrees which way?
Counterclockwise.
Yeah, 120 is positive. Go counterclockwise. All right, so right 3. I go up 90. And remember, each section is 15 degrees. So I went 90, 15, and 15 more. That's 30 past 90, which is 120. And that's it. That's my coordinate. All you do is put a dot right there.
Are you going to give us like graphic?
Am I going to give you graphs? Like graph paper? Yeah, on the test you'll have the graph paper. Yeah. For tonight's homework, I do have graph paper, but I think it's all rectangular graph paper. Okay, if anybody wants polar, let me know. I can just print them out. Yeah, I'll print them out and I'll have it by the end of the day. There's a website. You can just go on Google, type in polar. You can type in how many grids you want per page, how big you want them, and it'll do everything. Okay. Alex wants some too? We'll get Alex some graph paper. Okay. Questions on graphing that? Okay. Okay. 5 comma pi over 4. Okay. This time your radius is positive, your angle's positive. But Nathan, what's the difference with this one?
It's in radians.
Yeah, this is in radians. Okay, so if we're not sure where this is, might be a good idea to change to degrees first and then graph it. Okay. Does anybody remember what that is in degrees? Yeah?
I'm not sure what it is, but you do 180 over pi to figure it out.
Yeah, you could just take kind of off to the side, 180 over pi. So we really end up with 180 divided by 4. It's 45 degrees. Okay, this step isn't necessary if you know that in your head. Okay, if you need to, go ahead and do it. And John, can you tell me how I graph 5 comma 45?
You count out 5 rays on the pole.
Yep, which way?
It would be counterclockwise.
So for the counting out the rings, it's left and right. But I like that for the angle. We're going to go counterclockwise.
You go right.
Yeah, right 5. And then counterclockwise, 45 degrees. Okay, questions on that one? All right, let's try one that has a positive radius, negative angle. 5, negative 210. Charlie, yeah?
You go over 5.
Yep, and which way?
Right.
Yep, so just put a mark there. That's where we're going to start from. And then which way is negative 210? We're going clockwise. Okay, so I'm going to go, I'll start with halfway around. How much is that? That's 180, and I got to go 30 more. Because 180 plus 30 is 210. And that's it. Okay. Questions on that? Right, there's really no need to draw an arrow showing which way we went, because we actually could have went a different way to get there. But all I care about is the final answer. All right, negative 3 pi over 2. Zach, just to make that a little easier, can you tell me what pi over 2 is in degrees?
90.
Yep, 90. Okay, so Analia, what are we going to do for our radius this time?
Go to the left.
Yeah, this time we're going to go left 3. And now from that spot, you move 90 degrees. We just had it. Counterclockwise. Okay, 90 degrees counterclockwise. All right, so where's that going to put me? If I go 90 degrees counterclockwise from that spot. Yeah, it's like it's going down. And where do I stop? Yeah, right, basically where 270 would be. All right. So this one I'm going to draw just to show you how we got to it. Okay, we went left, counterclockwise. What's another way we could get to that point? Anybody give me another coordinate that would get me to the same spot? Yeah? Let's see, 3, 270. So if we did it that way, we'd go right 3, 270. Yep, perfect. That would bring you to the same spot. Okay, anybody give me another one? Yeah, John?
3 is negative 90.
Yep, that's another one. You could go right 3, and then negative 90. And there's one more. What do you think the radius is going to be, Charlie? No.
Negative 3, negative 2.
Yep, negative 3. So this time we go left 3, and then negative 270. That's clockwise this way. Negative 270. So how many ways are there to get to that point?
4.
Yeah, there's 4 basic ways to get to any point in polar. Okay, you have a choice of left and right. That's 2 choices. And then you have a choice of clockwise or counterclockwise. Right? So you have 4 different ways to get to every point. Now, if we did something like go to the right and then go around and then go around twice, that's not a different way. Okay, that's a repeat. You're just adding extra revolutions. Okay, but there's 4 basic ways to get to every point. Hey, any questions on that one? Okay, I'm not going to show this for all of them, but this one wasn't hard to do, so I just wanted to show you all 4. All right, this time we got a negative, negative. Okay, Andy, step 1, what do I do?
Left negative 2.
Go left.
Left 2.
Yeah, just say left 2. Okay, start from there. And then which way? Clockwise or counterclockwise?
Clockwise.
Clockwise. Okay, and go around. Land right there. Would it make a difference on this one if we did clockwise or counterclockwise? No, this time it wouldn't because you're going halfway around. Okay, so you can't tell the difference. But if it wasn't 180, you couldn't. Okay. Questions on that one? It's a negative, negative. All right, let's try one with a 0. Okay, this time my radius is 0. My angle is 300. What do you think is going to happen here? Kelly? Yeah, okay. We don't go left and right at all. We just stay right where we are. And we spin in place 300 degrees. Just make sure you stop spinning at 300. Okay. I'm going to look for that on the test. I look for the spin. I'm just kidding. I don't look for the spin. Just put the dot right at the origin, okay? You guys are looking at me like he's nuts. So 0, comma anything is always at the origin. Let's switch it up and try something comma 0. Okay, is that going to be at the origin? No, where's that one? Just move one right. Okay, so anytime your angle is 0, you stay on a horizontal line. You just move left or you just move right. Okay, any question on that one? Okay, so that covers all the different cases, positives, negatives, and 0. All right, next question. This is kind of getting it, taking the same point and writing it different ways. And if you want it in degrees, that's probably a little easier to work with. Okay, I've got the point 330, and I want to write it 3 different ways. Okay, one way I want to write it is a positive radius, and I want an angle between 360 and 720. Okay, next way I want to write it is with a negative radius. I want the radius smaller than 0, and I want a positive angle, okay, between 0 and 360. And the third way I want to write it, I want the radius positive again, just like number 1. Except this time I want a negative angle between 0 and negative 360. Right, so the easiest way to do it is usually to sketch it so you can see visually. Or if you can do it in your head, that's fine too. Right, so I'm just going to graph 330 so we know where it is. All right, so from all these problems, you've only got 2 choices for R. Okay, if you want to land on the 3rd ring, what are your 2 choices for R? You have to use 3 and negative 3. If you use something other than that, you're not going to be on the 3rd ring. I didn't mention this, but you can go in between rings too, like 3.5, that's fine. Just like in graphing, we can go halfway between 2. All right, so how about Jake, what's my radius for number 1?
360.
Radius. So what ring am I going to be on?
It's 0.
You want to help him out? What ring are we going to be on?
Oh, it's 3.
Yeah, 3rd ring. All right.
I was looking at that part, I was just looking at 1, 2, and 3.
Okay, and they want an angle between 360 and 720. Okay, so this is kind of weird. All they want me to do is make the angle bigger. Well, how can you make 30 degrees bigger and land at the same spot? Yeah, just add 360 to it. So if you add 360, what do you get? 390. I really consider this as a repeat of the original. You still have a positive radius. You still have a positive angle. You just decided to go around an extra time. It's really the same thing. These other 2 are different directions, though. We might go counterclockwise, or we might go left on the radius. All right, so for number 2, Paige, what does my radius have to be for number 2?
3.
Well, what do they want for a radius? They want R to be
Less.
less than 0, yeah.
Negative 3.
Yeah, so it has to be negative 3. All right, so we're going to go left 3. We're going to start from right there. And they want the angle to be positive. Right, so Dakota, which direction is positive angles again?
Counterclockwise.
Yeah, counterclockwise. So we're going to go like that. Okay. How many degrees is it from that X to that dot? Might be easiest just to look what's halfway and then how many you went past it. Make it a little bigger.
210.
Yeah, so 180 is halfway, and then 15 and 15 more. These lines are broken up as 15s. Okay. So that's 210. All right. That fits what they wanted. Negative radius, positive angle. All right, last one. Okay, this time they want a positive radius and they want a negative angle. Charlie? Do you have a question?
Yeah. From the X spot.
Where I was before?
Yeah, we just did negative, so we took a, how do you get to that other point?
So we got to go, it's positive angle, so we got to go counterclockwise. All right, so this is opposite way the clock would go. So,
Is that the original?
yeah, this is where we want to end up, and this is where we start. Because we went left 3 this time. All right, and, okay, last one. Hannah, what's my radius going to be on the last one?
3.
Yep, radius is 3. So we're starting right there. And negative angle means we're going to take the long way around and go all the way this way. Okay, so how many degrees would that be? Yeah, Nick?
330.
Close. 330 would put us down here.
Negative 3.
Yeah, negative 330. Okay, so any questions on how you take a point and write it different ways? Okay, the only one I didn't do here was a negative radius and a negative angle. Okay, I didn't do that one. Yes?
So writing it different ways is just like getting it to the same point like we did before, right?
Yeah. Yeah, and this is something that's okay, very different than this kind of graphing. If I can find it. Okay, with this kind of graphing, if you want to get to this point, there's only one way to do it. You've got to go right 3, up 1. Okay, I can't say, give me another way to get to this point. There isn't. But with polar, there's multiple ways to get to the same point. Okay. Any question on that idea? Okay, so in rectangular, only one way to get to the same point. Polar, many ways. Okay. Any questions on graphing in polar? We're good counterclockwise and clockwise?
Yeah.
Good? Okay. All right, so we just went through all these examples. All right, and last thing we'll look at today is how we change something that's in polar back to what we're familiar with, rectangular. All right, so what I'm going to do is just start with a point. You don't have to draw the circles. It doesn't really matter. Just put a point anywhere in quadrant 1. Okay, that point has a distance to the pole. What do we call that distance from the point to the pole? Not the slope.
Radius.
Yeah, that's your radius. Okay, if you wanted to think of it on a circle, it would look like this. Okay, it's the distance from the point to the pole. Okay, and then this segment here, what else would we know about it if it was in polar? We would know its radius, and we'd have an angle. Okay, that would be the angle right there. All right, I want to somehow get rid of r and theta, change it to rectangular. So what letters am I trying to get if it's rectangular? Not r and theta.
X and Y.
I'm trying to get x's and y's. Okay, so that's a horizontal distance and a vertical distance. Okay, what shape do you think we could make in this diagram to help us with that? Yeah, we can make a triangle. Right, so what I'm going to do, draw the height, draw the base, make it a different color so you can see it. Let's make it red. Let's go. All right, so there's my triangle. All right, so x would be the distance from here to there. Okay, that's left and right. Y would be this height from here to here. Okay, so our goal is to figure out how far to the right and how far up to get to that point. All right, so we've got a triangle, but not just any triangle. What kind of triangle is that? It's a right triangle. All right. So let's work with x. They're going to give me r. They're going to give me theta. I need to find x. Okay, we've done this a lot. What's the name of the side across from the 90 using words like opposite, adjacent, or hypotenuse? All right, so we've got hypotenuse. How about the side that's x? That's adjacent. What trig function has these two in it? Cosine, yeah. So cosine of theta equals, Nathan, what side is adjacent to theta?
X,
Yep, and the hypotenuse is
R.
r. What could I do to get x by itself? Multiply by r. And there's a formula for x. Take the cosine of your angle, multiply by r, and that'll give you the x. Does anybody have a guess what y is going to be? The formula, it's very, very similar, except it's just a different function. It's going to be sine instead. Okay, when we set it up, sine is opposite over hypotenuse. We're going to do the same thing. Multiply both sides by r. And that's how you get your y value. Okay, and when you're done, after you find x, after you find y, write your final answer just like that, as a coordinate. Okay, so changing polar to rectangular, it's all based on a right triangle. And these are the only two formulas you need. That's it. Okay, so there's same formulas again. Okay, so if you've got a point in polar, r is the radius, theta is the angle, use the following formulas to change to x and y. Okay. Yeah, same formulas you just wrote down. All right, so we'll try a couple of these and then give you some time to start the homework. All right, so our first point is 6 pi over 6. Okay, before I even type this in on my calculator, what should I check first? Yeah, I should check my mode on my calculator. What should I be in for this problem? Yeah, I should be in radians. Okay, there's no need for you to convert this by hand. Just change your calculator to whatever mode the problem uses. Okay, I'm already in radians. Okay. Right, so Brandon, what's going to be my formula for x? Just filling in those two values. You don't have to do anything out. I just want to know what I'm going to type in.
You would just do 6 equals
So it's x equals, yeah, but x equals 6.
sine 5 over 6.
Okay, just make sure you match up x equals with x equals.
Cosine pi over 6.
Cosine pi over 6. Yeah. Okay, good. And can you tell me what y is going to be?
6 sine
Good. 6 sine pi over 6. Okay, so let's just type it in and see what we get. 6 cosine pi over 6. That's about 5.20. You just round it off. And then 6 sine pi over 6. Okay, that comes out exactly 3. Okay, so I've got x, I've got y. What's my final step? Put it as a coordinate. 5.20, comma 3. Okay, any questions on that? That's how you type it in, just like that. Okay, what I want to do now, I want to graph this original point, and then I want to graph this one, and see if they really come out the same. If we did it correctly, they should. It should be exactly the same thing. All right, so this point is 6 comma 30 degrees. Okay, so it's right 6. 1, 2, 3, 4, 5, 6. 30 degrees. Okay, now what I'm going to do is take a rectangular grid. I'm going to drop it right on top of that. If we did it correct, this point should be a little over 5 units right and exactly 3 units up. Okay, so let's take a rectangular grid, put it right on top. Okay, does it look like it's a little over 5 units right and exactly 3 up? Make it bigger so we can see it. Does that look good? Yeah. It's exactly where it should have ended up. Okay. So if you have software on your computer, you can kind of just go between them just by putting different backgrounds in place and see if your answer is right. Yeah, on the graphing calculator, you can't really do that. But any questions on that? All right. Okay, so try that one on your own. Okay, see if you can convert -4 120 degrees to rectangular. First thing, okay, we have to get our formula for x. Ashley, what was your formula for x? What'd you get? Yeah.
Like, what was my answer or what was my formula?
Your formula.
-4 cosine 120.
Okay, -4 cosine 120. Looks good. Nathan, what'd you get for your formula for y?
-4 sine 120.
120. That's good. And then when we get x, Andy, what'd you get for x? 2. Yep, that one came out exact. And how about Brandon, what'd you get for y?
-3.46.
That one's a decimal. So just round to 2 places. And lastly, make sure you just write it as a coordinate. Okay, any questions on converting polar to rectangular? Okay, so to convert polar to rectangular, we use sine, we use cosine. Which trig function didn't we use?
Tangent.
Yeah, we didn't use tangent. We're going to use tangent when we convert the other way tomorrow. Okay, when you change rectangular to polar. All right, so homework for tonight, it's page 308. Okay, all evens. Okay, 12 to 26, 40 to 46. Okay, and as a reminder, this week we have a half day Thursday because of the conferences. Okay, so I won't be able to do my extra help Thursday, and then Tuesday I have a meeting right after work. Okay, so if you need extra help this week, it's going to have to be either before school or during the study.